Hello, welcome to my session. I hope you enjoyed the lunch and you are ready. But before we start, there's one thing. When I look at the agenda today, I found a talk which is a must-have for me. And you know what? It's now in the room number 1, so I will leave you here alone with the slides and I will go there, okay? No? Okay. So let me start seriously. My name is Piotr Stapp and I'm head architect at FinAi. Today I will try to explain why cloud is like alcohol and why it makes a big hangover. But before I start to talk and grumble about cloud and technology, I have to present what FinAi is. My marketing guy said the FinAi is the first online store with banking loans. What does it mean? That's a really good question. I don't know. But the most important fact is that by the law we are almost a bank. Exactly, we are an outsourcer of banking services. The only problem is that we are in the cloud. In startup era, a new startup must have a good name. Usually when they start to present what they are doing, they say something like, we are like Facebook for lawyers, or Uber for trains, or Instagram for IT departments. The last one I really like. Anyway, we are like a booking.com for bank loans. Assuming that you live in Poland, with our simple website and a mobile application, you can get a really cash loan offers from banks in 15 minutes. But what does it mean? To allow clients to get a loan while sitting at home and keep the process safe for the bank, we need to confirm client identity in a way that is AML compliant. For this purpose, we are using face biometry and ID authentication. The tools are embedded into our application and there's a lot of processing in the backend. Customers use our application to take selfie and photos of his ID card. Our system performs dozens of verification and security checks. During the loan application, bank needs a lot of information about us. Normally, it's a number of long and complicated forms that clients fills in. We redesign the process and collect information in a very convenient way because we have AI in the name. Yeah, artificial intelligence must be something easier. Anyway, at the end, clients get the binding offers, which are risk-based priced. So we need to integrate with banks' back-office systems using an API or a robot called Screen Scraper, but for not the front end, but for the back office. And that's the end of the marketing part. Now you know the context, so I can start talking about technical stuff and grumble a lot. 5 elements to make our project happen. First one, regulation in heart. You are a fintech by heart and soul. But according to the law, you are a bank. Regulation, paragraphs, lawyers' opinions has bigger influence to our IT design than you can probably imagine. I called my colleagues lawyers, IT architects. I'm not an architect. They have a bigger influence, seriously. Product obsession. I hope you understand. Small time, little money and unique vision make us to have an obsession on our product, to be the best on the market. Solving problems. Every problem consumes time. If we can reduce problem, you have more time to make our platform better. Simple UX. It's not me. I will skip it. And the last one, security. As you notice on the video, we are collecting two important things about our customers. A selfie. Okay, everybody collects a selfie. And ID card. If our data leaks out somewhere, we can probably close our shop immediately. So, cloud. Cloud is now a final frontier for IT departments, the first choice. So let me grumble a little about it. Well, cloud is like alcohol. First of all, you can overdose it quite easy. The result can hurt you, especially this thing, your wallet. It shows how weak is your team. Creating a proof of concept is like that. One day, few components, 10 clicks, and you have a working solution. But creating a product in a responsible way is much more difficult. But using cloud stuff, you can really do it fast. The start is even too easy. If you want to use a cloud, you choose one, for example, Azure. And you have an Azure free account, have 150 euros on it, and some products even forever for free or for 1 year. But the bill will come later. It's complicated. So why Azure? First of all, it's the first question which we hear from different people in IT. Why this cloud? If you remember, especially that there are a lot of different. For example, AWS is much more stable. They say that it's much more stable. Google Cloud is freaking awesome with Kubernetes support. Seriously, freaking awesome. Alibaba Cloud is cheap. It's China, but it's cheap. And much more. But if you remember our point one, it was regulations. Yes, regulation in this case have impact on our software creator. And Azure is the most compliant with Polish and European Union regulation in bank sector. I don't understand it, but they say that it is like that. For example, they can give you a document that makes sure that all your data and computation is inside the European Union. Moreover, Microsoft gave us a sponsorship, but don't worry, for sure we will pay them back. It's rather a bank loan than a sponsorship. Every cloud will give you a sponsorship in the beginning, and then they will wait a bit, and you will pay with a small percentage back. The last thing is our connection. For example, I'm Microsoft MVP. Our CTO was working close to Microsoft Technologies. We know guys from Microsoft well. We know guys from Microsoft community well. So it was easier. So, first thing, they say that clouds always works. So, simple outages from this year. For example, Google Cloud February has problem with Google Apps Engine. Affected apps, Pokemon Go and Snapchat. And much more, but AWS in March. The storm disabled direct connect dedicated links from the AWS North Virginia region. Affected apps, Amazon Alexa, Atlassian Cloud, that's the funny thing. Atlassian Cloud is on the AWS cloud. They don't have their own cloud. It's just cloud on the cloud or something. Slack and Twilio. So developers have a free day. No Slack. Let's go home. Third one, Office 365. April. A lot of customers in Europe, Asia and the US were locked out of their email accounts on April 6th. AWS in May. Affected customers were down about 30 minutes. EC2 and relational database service were just down for 30 minutes. There wasn't a way to restore the data. The data just disappeared. Sorry. Microsoft Azure in June. A particularly hot stretch of Irish summer hit the Azure data center and make a small failure. The sixth one, a few days ago, September, high energy storms hit southern Texas and killed south central US region. For example, application insights all around the world were inaccessible. Application insights is a tool for view and query logs inside Azure. The logs were collected properly, you just cannot view them. So, from 0 to hero in 12 months. Our MVP was ready in 4 months. So what happened in next 8? Our partners are banks. They don't buy stuff based on PowerPoint presentation. They need to see working MVP. They need to create penetration tests, meetings, lawyers, more meetings, more lawyers, more penetration tests. For example, they have to come to our office and check if our algorithm working well with their ID card. They have to check it personally. I understand them. But Greenfield project were feeling adrenaline in every aspect. But it cost chaos, for example, in naming things. We even forgot that everything in platform as a service has CPU and RAM under the hood. For example, we didn't monitor RAM usage, and one day on our test environment, it has just finished. And our test environment cell stopped. We didn't know what's going on, and from this day we are monitoring CPU and RAM. And the last thing is the backup. Backup in cloud sometimes does not exist at all until you do it by yourself. Maybe an example. It will be easier. There is an Azure Cosmos DB, which is a cool service, and it has built-in backup. Every 4 hours they back up all the stuff you have in your Azure Cosmos DB. To restore a backup, you need to write an email to Azure support. They store only 2 versions of it, so you have up to around 8 hours to write an email. If you forget about it, your data just is gone forever. But for another example, Azure SQL. Azure SQL is a MS SQL based on as a platform as service component, and you have a backup every 5 minutes. It's awesome, so you can go back in time every 5 minutes for last 7 days. And the backup exists until you delete the whole component. If you delete it by accident, there's no backup at all. It's sad, but too. The Microsoft suggests to make this component as undeletable. And it's kind of a solution, but another story is how to delete a component which is marked as undeletable if you really want to. So, naming things is hard, seriously. The old jokes say that the naming thing is the second hardest thing in computer science. The first one is invalidating cache. The first way is a total freedom. It's only create chaos. The names like test API or page www or Stapp don't touch it please, it's my name, is the way how the developers work. It's just only for 1 day. Seriously, the name doesn't matter. And 1 week later, nobody knows what's going on. But let he who's without sin cast the first stone, please. The last name was mine. So our first conversion was simple. let's prefix everything with our company name that adds an environment and in the end name the resource. And it works well, but for example, storage accounts cannot have a dash char in the name. They have to, so we replace it with 0. It's first A convention. And have a short name. I don't remember, 50 chars or something like this. The second problem is search. In Azure Portal and PowerShell, you can find out a component with starting writing its name, like FinAi, block, let's say dev, database. So you have to write the whole name to find the resource, because until you write the last one, because you are looking for a SQL, not for the web service, you just cannot see it. So the second convention was, let's change the order. First resource, then project name. But remember that your project name cannot be blog, just blog, because probably there is a company around the world who is also creating a blog. So they will, let's say, some names must be globally unique in cloud. Yeah. So the third convention was resource, project part, and project name. Because there were more than one SQL database, let's say, in microservice world. So in FinAi block, we have SQL 1 and SQL 2. We need to separate them, which one is which. And the fourth convention, the last one, and I hope it's the last our convention, is suffix, the third one with the region. We don't use default region in the names, but if we have a, let's say, backup or a copy in another region, we have just added the suffix with the region. So, no admin but DevOps, or even DevOps 2.0. Creating infrastructure is really easy using RM templates, so administrator has less tasks to do. Developers create infrastructure with help of administrators, but developers. A good CI/CD process is worth weight in gold. You need to automate a lot. It's a really difficult, but it has a great value. So if you did something once, automate it, so you don't have to repeat it again and again. But some parts we just cannot automate. We tried and failed. Like VPN, configuration, Active Directory, some configs. But what was our way to RM templates? First, in my first weeks, I tried Terraform, which with Azure. But I failed. I just failed because I need to write too much custom stuff inside. But I heard that it's coming back and it's better. Maybe it's time to check it again, but probably one day in the future, so I will do it never. Doesn't forget, sorry. Then I tried RM templates, and it looks like a almost a silver bullet for Azure components. With RM templates, seriously, you can do almost anything until it doesn't work. So then you use a PowerShell scripts or a REST calls to Azure resource website. And if all above sucks, you need to click something in Portal. Still, you need to sometimes click something in Portal. Okay, but to make it simple, we tried to make all our components to deploy with one line of code. Every component have the same line to set up. Deploy, environment, and everything above or under the hood is doing PowerShell, RM templates, and so on. We don't have a centralized one script to rule them all. Why? Because it's too easy to destroy others' work with a bad line in your part. If we have everything in one file, it will be too difficult to manage. So, next part, security is really hard. Manage permissions. Oh my God. For example, Azure DevOps, known more as Visual Studio Team Services, has more than 200 permissions. Seriously, 200 permissions. When I'm a developer, I know three kinds of permission: admin, read, write. Yeah. Okay. But cloud is public, so if you forget to manage it well, everything is accessible to everyone around the world. You need to think about, with security, you need to think about security blocks from, let's say, application level to network level, with database level, and so on and so on. In classic on-premise solution, the biggest security level, security block maybe the better, is the physical access to the data center. You need to go with the laptop and connect. With the cloud, it doesn't work like that. Moreover, managing secrets, it's much more difficult. In my life, I saw many solutions where the password was in plain text in configuration, and they say, it's okay, nobody will ever access our data center, so who cares? In cloud, you try to make your secret more secret. So, for example, we are using Azure Key Vault for certificates, passwords, and connection strings. But we have first data leak some time ago. The cookbook was one IAM template plus deploy, then few clicks in Azure portal, and redeploy. Redeploy, this means all the stuff we clicked in the Azure portal. And result was that all ID cards of our employees were accessible for 1 week in the internet. Everybody who read the correct URL in the browser can download all our ID cards. So that's why we decided to move our infrastructure from the public networks to private networks to add one more block of security. But in Azure, it's called Application Service Environment to have a PaaS components in private network, and it starts from €900 per month, just to have it. And then you pay for the PaaS components as normal or even twice as much. So we have two, one on the test environment and one on the production. Service-to-service authentication. Second level, or second block of security. So your service talks in the, maybe not 100% public, but in the cloud. So you want to make sure that it is your service connect to your service. It's not something, let's say, from my computer. What standard is JW tokens? And Microsoft suggested as a really good idea and used the JW token from Azure Active Directory, which is really a good service. Seriously, Azure Active Directory, in my opinion, is the best part of the Azure stuff. But the funny thing is that inside JW token, there's a service name, principal name, written in plain text. In this case, it's a unique identifier. Yes, such awesome. Unique identifier for your app. How can I check if it's this stuff? It's my app. But there's another thing. You can add group tokens inside JW token to make easier to make authentication and authorization of your service. But by default, it's not present. You need to change application manifest in Active Directory. And the command is really simple. One line. Gosh, it took me 10 hours, seriously, 10 hours of searching and Googling to find out this stupid command. Maybe I'm stupid or something, but life is life. So learn something new every day or die trying. Cloud is not a tutorial, below a few issues from last year. Azure Functions. One day Azure team decided to upgrade newtons of JSON and all our functions just collapsed. Doesn't work at all. Redis and thread pool. We just open Azure Marketplace. We need a Redis, so we clicked yes. And we have a lot of deadlocks everywhere, because default configuration is just a piece of crap. That queues on Azure Service Bus. This is one of my favorites. We have a health check to check if our service has something in that queue. If we have something in that queue, it means that something is really bad. Probably our client is dying. So we call the service bus to ask, hello, is there anything in that queue? And so from time to time, service bus stops responding in short time. So we have more calls without an answer. So it caused that in 2 hours we generate 1 million errors in service bus service. Just like asking, hey, is something wrong? When we ask more, it was more wrong because we asked more and so on. If you are from the .NET world, there's one more thing. There's more chaos created with .NET Core, .NET Standard, .NET Framework. And you know what? A few days ago, they open sourced the documentation. So if you found a bug, you can fix the source because it's open source now. And you also can fix the documentation. I remember the times when Microsoft documentation was rock solid. But now we live in preview, or second preview. And the last but not least, there's a new pattern called conference-driven development. For example, our colleague yesterday had a workshop using Azure Functions. But you know what? This week there's a Microsoft Ignite conference, so the UI just has changed at all. New features. And the worst thing is that my colleagues from AWS and Google Cloud told me the same. When there's a big conference, stay at home and don't look on your services, not to stay. And one more issue about service bus cookbook. We use queues. Queues are good. Implement them over service bus because it's a native way to use in Azure. Use schedule later method. Result, no message at all. Seriously, few messages just disappeared. In logs, we logged info. We sent a message with a success. The method returned true, so we write down success. So we write an email to support. Hello. What the fuck? They answer, oh, we have a bug in the library, and when something in our service bus, then something, and your messages, it's a small issue. Okay, please upgrade your nugget to preview 1. So we did it. We add more logging in our application just to make sure that if we schedule a message, there's some time later it's handled by a service. And we find out that still some messages just ping. So we write them again. They say, oh, upgrade to preview 2. And now the state is that we didn't find any message that it's lost in space. But I'm not sure it's still working good. Okay. But cloud can be also awesome, seriously awesome. We built an online data warehouse in just a few days. Online means that time to market, so from click to the data warehouse, is maximum 5 minutes. When I tried to write such service long time ago, we spent almost a year. This system was created in few days. Every developer can add a new event just with one line of code. Then we have event collectors using Azure Functions. Then we have a storage queue just for queue system. And we have a real-time event processing. We store the data in the SQL and the blob for the future usage if we really need it. It's magic. Simple solution that brings a great value. Data model. Creating a data model is quite tricky. My colleagues from data science, let's say department, make it quite easy to access. So we have a few models like liveness detection, face detection, ID card detection, hologram on ID card detection, and so on. To install it, we use a simple Docker. I want to use Kubernetes, but we need GPU on board. To run a model, we need a GPU. It's like 15 times faster on GPU, so the normal took on GPU it's 1 second. Without GPU, it's more than 1 minute. So we have to use GPU. But there's an issue, okay, not implemented feature in Kubernetes, that you have to have, for such Docker, you need to have one GPU, one machine with GPU. You cannot share the GPU between containers. When on the normal virtual machine, you just can with the NVIDIA something plugin. So starting price for the GPU machine is 700 euros a month. And in Kubernetes and our applications and multiply by the environments, it was just too much. So we decided to use a bare virtual machine. It's just cheaper. Patterns and DevOps are good, but not always. Sometimes the money is more important. How does it work? Based on a photo series, one mathematics and one physics, and some clever papers, created a few fast algorithms to detect and verify ID card. I'm stupid, so I don't understand what exactly they did. But if you want to ask them something, just write me and I will give you a contact and you can talk to them probably for a night or two and they will explain everything. They are really good at it. To summarize, architecture. 50 separate stateless services which can be scaled separately. Not exactly, but separately. Implement using .NET Core, .NET Framework, and Python. Why full framework? Because there are some components which are still not ready in .NET Core or something like that, like PDF stuff. And Python, of course, for data science models. All is in Azure infrastructure. Data is stored in platform as service databases, Azure SQL, Cosmos DB, and Azure Storage. We have also a node PaaS database for the data warehouse. We are trying, maybe it's better, online replication to the second region. But we didn't test it, so I cannot put my hand that it's working still. We are in progress. Data is partitioned by user, so data sharing is possible in a few ways if we really need it, like regional, national, technical, and so on. We mixed platform as a service with infrastructure as a service because sometimes it's cheaper to create a virtual machine for 7 euros just as a reverse proxy to the PaaS component with VPN inside, or pay more for the PaaS component like 100 euro without this virtual machine. Microservices. We tried to make event-based microservices for internal and external dependencies like biometry, banks, government service, email, SMS, and so on and so on. We try not to have centralized components, but it's not 102. We run it in application service environment, and we are planning to migrate to Kubernetes because it's cheaper. That's the main reason why we want to migrate to Kubernetes. It's the cost of the infrastructure behind. We have unit and integration tests built in. We have multiple health checks in every component, like is there anything in service bus. DevOps and testing. Everything is automated from infrastructure to deployment. IAM templates for infrastructure, build definition in Azure DevOps, fake builds for .NET projects, because Marcin is an F# fan, so he introduced fake, and we have C# and F# on the board, and all our scripts are in fake. In average, we release 2-3 times a day on production, including farm and deployment. Seriously, I was shocked when last Friday my QA and release manager write me, install it on production. I was, man, it's Friday, it's 4 p.m. Are you serious? Yes, I am. Oh my God, okay, deploy. He was the first person who said there won't be any Friday deploys. And now he's so sure that we can deploy even on Friday, Sunday, Saturday. Shiny new environment can be set up probably in a day, if we need it. The only problem is with the integrations around us, and we will have to copy configuration and use from another environment or do something else. We have full pack of end-to-end tests, runs every hour. We have more than 50 cases in our process using Selenium Grid in .NET, but using Selenium. We also we test multiple browsers using our internal Selenium Grid and browser stack if we don't have such browser. For example, we have a case that our website was totally cropped in Firefox 41, which was released 2 years ago, but one of our banks had exactly this version. And on exactly this version was a piece of crap. Our application was a piece of crap. Firefox was Firefox. Okay. So, and more, what's more, we have regular performance benchmarks to make sure that everything is fine. Data-driven, we are data-driven. Our CTO is data freak, so data everywhere. And why it costs so much? Because we are logging everything. But why it costs? Anyway, we are data-driven. We have sensitive data separated from the day one on architecture level. We have a customer service. That's the, let's say, this common part of the data. If you need secrets, sometimes you need it just to, for example, you need your parcel to apply to the bank, so you need to get it from the customer. You have more than 450 measure points in system. We measure UX, we measure backend, we measure CEO, we measure SAM, everything what can be measured, we try to measure. And we have online data warehouse, which I presented before. So, can we quit the cloud? No, I hope so. Until regulations doesn't change, I hope we will stay in the cloud, but we are ready to quit it. We have to think about our software in regulation, let's say, patterns. So if the regulation change, we want to be sure that we can escape the cloud. It won't be easy, and I hope so we will never have to check if it's still possible. But we learn a lot during last 18 months, and we learn new things every day. We create our own spaghetti code sometimes and our own technical debt, and we are trying to fix it. We learn what is good and bad in our team and in our cloud. There's no component in Azure which we used and it wasn't work as expected for all the time. We have written a lot of tests and logs, and we are written every day. But the main quote is that we learn one important thing. Cloud doesn't solve problems, but it changed the way how the software is created. Because you don't have to write everything, you can use components to make it faster. And the question in the end is it only us, or you have such same feelings about the clouds? I hope so, you have such same feelings. So the contact. If you need to write me, I have unique name. It's Piotr Stapp. You can write on this address. You can write also on my private address. Find me on Google, Facebook, or whatever. If you have questions, please come here because I cannot see you, and I have a small disability. If I cannot see a person, I don't hear the person well. Seriously, I have a problem with my ears. So if you have questions, please come down, and that's the end. Thank you very much.